Budgets are typically prepared before the beginning of the financial year and serve as the financial targets for the business. Forecasts, however, are updated throughout the year, typically on a monthly or quarterly basis, as each financial reporting period closes and actual results become available. In this video, we'll see how Fabric Plan supports this process by combining manual forecasting with Predict. We'll begin with a manually created forecast, replace the closed periods with actuals, and then use Predict to generate a statistical forecast for the remaining months. We're starting with our base view with region and product category hierarchy on the rows and year, quarter, and month on the columns with actuals for 2024 and 2025 already loaded. First, let's create a 2026 target. This is a simple data input measure. Let's quickly hide the 2024 measure. Let's enter the annual target for 2026 here directly and allocate it based on 2025 actuals. This serves as the benchmark for evaluating our forecasts throughout the year. Now it's the end of December 2025, so it's time to create the first forecast for 2026. Let's create forecast version 1 with an open period from January through December 2026. We'll enter the forecast values manually based on our understanding of the business and expected performance for the year. This gives us a baseline forecast driven entirely by business judgment before introducing statistical forecasting. Now let's fast forward to the end of the first quarter of 2026. Actuals are now available for January through March. Now we'll retain the original forecast values from January to March, and then close the period of forecast version 1 till March 2026. This allows us to compare forecast against the actual results and understand how closely the manual forecast matched reality. Next, let's create forecast version 2 with an open period from April through December 2026. Instead of manually updating the remaining months, we'll use the Predict feature to generate the forecast. Let's select the total cell for the forecast measure and click Predict. First, we'll verify that the historical period and forecast period are correct. Under Configure Forecast, we'll set the confidence level to 90% and apply a 12% growth to it. We'll choose Bottom-up evaluation so the forecast is generated at the most detailed level before rolling up. For the forecasting algorithm, we'll choose exponential smoothing, as it works well for time series data with trends and seasonal patterns, such as sales and demand. We'll set the model to Auto ETS, allowing the engine to identify the best fitting model automatically. Since the data follows a clear quarterly pattern, we'll set the seasonality to quarter. Now, let's run the forecast. On the next screen, we can fine-tune parameters such as alpha, beta, gamma, and phi. These control how the forecasting model responds to changes in the historical data, including the level, trend, seasonality, and trend damping, respectively. For this video, we'll leave them on auto and let the engine determine the optimal values. Here we can preview the forecast. Historical values appear in gray, forecast values in green, and the confidence interval is displayed around the forecast. We can also switch to a tabular view to review the results. Everything looks good, so let's save the forecast. Our forecast version 2 is now in place. As new actuals become available, we can continue repeating this process, keeping the forecast current throughout the planning cycle. We've now created a rolling forecast by combining manual input with statistical methods. As new actuals become available, we can generate updated forecasts for the remaining periods while preserving every forecast version for comparison. This gives planners a continuously updated view of future performance without losing the history of previous forecasts, making it easier to monitor accuracy and refine planning decisions over time.